In this lesson, I'll show you an example on how to use logarithms to differentiate non-logarithmic expressions. Let's get started. We have to differentiate the following function. And it's important to note that logarithms are sometimes used to aid in differentiating non-logarithmic expressions. Derivatives of some complicated expressions such as this one can be found more easily if we first take the logarithm of both sides. So let's do that. Taking the natural logarithm of both sides, we get ln y is equal to ln of this expression. So we have ln bracket, and everywhere that you can see a radical, change it to exponents. X minus 2 to the power of half. This is the third root of x plus 3, so that becomes x plus 3 to the power of a third over x plus 1 to the power of a fourth. Now we can use the rules of logarithms, and those rules are shown on the screen. Since this is a quotient, we can subtract the upper part from the bottom part, where we get ln y is equal to ln of the upper part, x minus 2 to the power of half, times x plus 3 to the power of a third, minus this part now, ln x plus 1 to the power of a quarter. The next rule that I'll use is the product rule, and that tells us that if we have a factor representing ln, then this can be split up into sums. So we have ln of x minus 2 to the power of half plus ln of x plus 3 to the power of a third minus ln, and this part stays the way it is for now. The last rule that we will use is the power rule, where if you have an exponent and we have the following case in each of these terms, it will be multiplied to the term instead of being written up here. So this becomes 1 over 2 ln x minus 2. This becomes 1 over 3 ln x plus 3. And this becomes 1 over 4 ln x plus 1. And the left side remains the way it is. Now we will differentiate with respect to x implicitly. So starting over here, we have ln of y, that becomes 1 over y, and the derivative of y is dy over dx. That part is taken care of. Finding the derivative of these three terms with respect to x. Let's start with this one. We have 1 over 2. X minus 1 goes at the bottom. Make sure that you put it in brackets and then take its derivative. The derivative of this is equal to 1. So technically we multiply this by 1 and you should end up with the same expression. Over here we have plus 1 over 3. Once again, x plus 3 at the bottom. The derivative of this is 1. Leave it the way it is. And lastly, 1 over 4. X plus 1 at the bottom. Taking the derivative of x plus 1 is simply 1. Now all we have to do is solve for dy over dx. You can do that by multiplying both sides by y. Just cancel this y, and we multiply all of this by y, giving us our final answer of dy over dx is equal to, I'll place the y at the front, 1 over 2 times x minus 2 plus 1 over 3 x plus 3 minus 1 over 4 x plus 1. Now that we found the answer, as a challenge for you, find the derivative of y is equal to x to the power of 2x. I want you to take the derivative with respect to x and write the answer below in the comment section. And so there you have it. That is how to use logarithms to differentiate non-logarithmic expressions.